So we're going to talk about this thing called the hinge theorem, and in GeoGebra I've created two segments and I've connected them. One is 4 units long and one of them is 6 units long, and they're connected at the vertex of this angle, and you can see why this is called a hinge theorem, because it's almost like it's a door on a hinge. I've made one of the segments 4 units long and one 6 units long. It doesn't really matter though. We've got 2 different segments. I'm going to throw the measure of the angle in there too. And that angle is going to change as I move that one side of the triangle or the other. So we can see that the wider the hinge, kind of the bigger the angle. If I turn that into a triangle by putting a third segment in there, we can see where this is going. The bigger the angle, the bigger the side, right? We talked about that yesterday. And again, as I move that side, the bigger the angle, the longer that third side gets. So I've duplicated this triangle for you. These 2 triangles are the same side. The hinge theorem just says that if we have 2 triangles with the same side lengths, in this case 6 and 4, and one of those triangles has a larger angle between the 2 sides, then that third side will be longer. So I moved one of the vertices, and now we can see that the length of this side is 6.8, the length of this side is 8.9. Not really a big surprise there. The bigger the angle, the longer that side. So really that's what this whole section is about, is just comparing sides in 2 different triangles, or comparing angles in 2 different triangles. No big deal. So we have the hinge theorem and its converse are both true, and it basically says just what I just told you. If 2 sides of one triangle are congruent to 2 sides of another triangle, so we're talking 2 sides, and then we're going to look at their included angle. So the included angle, again, is the angle between those 2 sides. So here we have this side and this side. VW is congruent to RS, and VX is congruent to RT. If the included angle of the first triangle is bigger than the included angle of the second triangle, then guess what? That third side will be longer than that third side. So no big deal. It's a hinge theorem. Again, it's like V is the hinge and we're opening up that doorway, or R is the hinge and we're opening up that doorway. The wider the angle, the bigger the side. Its converse is also true if 2 sides are congruent to 2 sides of another triangle, and the third side of the first is longer than the third side of the other. So in this case, we have AC congruent to DF and CB congruent to F, whatever that letter is. We see AB is 12 and this side is 9. That means that this angle, the angle that's included between those 2 sides that we know about, would have to be bigger than this angle. So it's kind of common sense, bigger angle, bigger side. So the book uses this kind of example. Given that ST is congruent to PR, so ST congruent to PR, we can see that marked in the diagram. We also know that PS is congruent to itself by the reflexive property. And here's the other thing we know. This is kind of a goofy picture. RS is 23 units long and PT is 24 units long. How does measure of angle PST, that's this angle, compared to the measure of angle SPR, that's this angle, and we would say that measure of angle PST is greater than the measure of angle SPR because PT is larger than RS. So kind of, again, making sense. The diagram's a little misleading because it almost looks like those are 2 congruent triangles, but they give us the measurement, so not congruent. And then the converse of this theorem, given that JK is congruent to KL, how does JM compare to LM? So here we know an angle and a side. Because 64 is larger than 61, we would know that JM would have to be larger than LM. Again, common sense. And then the book likes to give you these. They call these real-world questions. I don't know how real-world this actually is, but we've got 2 groups of bikers leaving the same camp. So they're leaving here, and they are heading in opposite directions. So one's going this way for 2 miles. One's going this way for 2 miles. Once they reach those 2 miles, they're going to change direction, and they're going to go 1.2 miles. So this group goes 1.2 miles with a 30-degree angle this way. and this one goes 1.2 miles with a 45-degree angle here. The question is, which one is furthest away from the camp? Well, we would draw that line directly back, as we like to say in the outdoors, as the crow flies, directly back to camp. These sides are congruent, and these sides are congruent. So we're looking at the included angle between them. Well, the included angle, if this is 45, this must be 135. And if this is 30, this would be 150. And again, hinge theorem would tell us, because we have those two congruent sides, the angle opposite the larger angle would be the longer side. So group B is further away from the camp. And that's it. We're just going to go to the book and practice a few of these questions. So page 335, let's do the evens. And that's it, guys. Hope to see you soon. Bye-bye.